Hello, everyone. Today, we will delve into the input and output interface circuits of PLCs. The input and output interface circuits of a PLC serve as the link and interface between the PLC CPU and the field's input and output devices. Let's start with the input interface circuit. PLC input interface circuits come in two forms: DC input circuits and AC input circuits. The DC input circuit operates on a 24-volt DC power supply, while the AC input circuit uses a 220-volt supply. Now, let's take a DC circuit as an example to illustrate the composition and principle of the input circuit. A PLC's input interface circuit typically consists of four main components: the power supply, input terminals, optocoupling, and internal circuits. As shown in the diagram, the power supply is external to the PLC. When the input switch closes, current flows from the positive terminal of the power supply through the input terminal I0.0, passes through the optocoupler, the light-emitting diode, to the anode, and returns to the negative terminal of the power supply. The light-emitting diode, mounted on the PLC's panel, indicates the status of a specific input point, showing whether a signal has been received. Input contacts can be passive, such as button switches or formation switches, or active, like proximity switches or various sensors. It's important to note that when the input is a continuously varying analog quantity, such as temperature, pressure, flow, or level, it must undergo a deconversion before being sent to the PLC. This is our input interface circuit. Next, we explore the output interface circuit. To accommodate different loads, there are three types of output interface circuits: relay output, transistor output, and thyristor output. The relay output is the most commonly used. The external load at the terminal can be powered by either DC or AC. As shown in the diagram, when the relay is energized, the K contact closes, connecting the load to the power supply through K. The relay output is characterized by its strong load capacity but slow action frequency and switch response speed. The transistor output interface uses a DC power supply. Once the transistor conducts, the load receives a 24-volt power supply and operates. The transistor output is known for its high action frequency and fast switching speed, but has a lower load capacity. Another is the thyristor output circuit. The thyristor output circuit functions as an AC electronic switch. It shares characteristics with the transistor output: high action frequency, fast switching speed, but with a smaller load capacity. Let's use the PLC relay output as an example to explain the composition and principle of the output interface circuit. The relay output circuit generally consists of internal circuits, relays, output terminals, and a power supply. When the internal circuit Ka contact closes, it is equivalent to the output Q0.0 being activated, and the output loop load is powered. On the PLC's output panel, there are light-emitting diodes that indicate the output status. Output devices such as indicator lights, contactor coils, and solenoid valves can be connected to the PLC's output terminals. The output load power supply is selected by the user based on load requirements, such as DC or AC power, voltage levels like DC 24 volts or AC 220 volts, and capacity. The first function of input and output circuits is signal transmission. They convey external signals through the input unit into the PLC and send execution results from the output unit to control field equipment. The second function is to perform level conversion. The CPU typically outputs a DC 5-volt signal, while I/O signals may be DC 24 volts or AC 220 volts. When the two communicate, I/O modules are needed for voltage conversion. The third function is noise isolation. Photoelectric coupler in I/O modules also prevents external extreme voltages and interference from affecting the CPU module or disrupting the PLC's normal operation. That concludes our study for this lesson. See you next time.